on the stairs, this side it's shake.
ओ भाई साहब याला कुठून आणले उचलून अरे बा
Let's sit down fast so that we can start.
They cannot accommodate everybody.
अभी से मत ले रोहन बाद में ले ले टाइम है चालू है
Well, I'm going to try without the microphone. Tell me if you can hear me.
या
Can you hear me?
या
Put your hands up if you can hear me. In that case, I'll stay on with the microphone.
yes please
My name's David. I work for a company called Science Made Simple. I've got a fantastic job. I travel all over the UK, all over the world, talking to incredible people like you about science, technology, engineering and mathematics. Some people call those STEM subjects. And today's STEM show is called Water, Water Everywhere, or is it? So put your hands up if you like water. It's good. Now, a trickier question. Put your hands up if you like science. Given that you're at a science festival, that's quite obvious. You're in the right place, because this show is all about where science and water bang into each other. And they bang into each other a whole lot. And we've lots to think about, so let's get on with the show. Now before we start, I've got a very odd question to ask you. You see, somewhere in this room, in this space, there is an alien thing. Can you see the alien thing? Can you see anything in here that might look like an alien? Over here? Now, that was a fantastic answer, because this isn't an alien, but it is a model of an alien. The actual alien is in this glass here. Water is an alien substance. Water does not belong to the earth. Well, to be accurate, I better say, a lot of water doesn't belong to the earth. It crashed into our planet millions and billions of years ago on the back of asteroids. Huge lumps of rock. In fact, about half the water on our planet wasn't made here. It came from space. Water is an incredibly old thing. Now, because water is so old, millions and billions of years old, that means that water can have existed in lots of different places. So water might have existed, so the water that's in you now, and me, and your teachers, might at one time have been snow at the North Pole. The water that exists in you and me now might have been to the North Pole. Now I'm not saying it definitely did, but it could have been. The water that's in us now could have existed on the North Pole. It gets even crazier than that. The water that's in us, it's so old, it could have even existed inside a dinosaur. Whoa. I know, it gets you, doesn't it? Water is so incredibly old that the water that's in us now could have existed inside a dinosaur. Strange but true. That's how crazy water and water science is. It's going to get a lot worse before it gets better, people. So we better start. We better start by using our powers of observation. I've got some water in this cup in front of me. What colour is it?
Colorless.
Transparent. That's a fantastic word. Any other words? Clear. Any other words? Whoa. Now the lady in the yellow shirt here said colourless. That is a fantastic. Give this lady a round of applause. Because if you're trying to be a scientist and science is all about accuracy, then the best, it is transparent, it is clear. But the best way to describe it, the scientific way to describe it, is colourless. Now, what does it smell like?
कसं करते येऊन तर बघा
Smell like? Nothing. What does it smell like?
पळा इट्स लाईक नो स्मेल
मिसळीच नाही काही तर कसं माझी
The lady over here says that it doesn't have a smell, and it doesn't. It's odorless. So we've got colourless and an odorless thing. What does it taste like? Now I'd love to give you all a taste of this, but it would take the whole. In fact, it would take about 6 hours. So I'll do it myself. Here we go.
Tasteless.
So what is it? Tasteless. So we've got here are not colourless, odorless, tasteless. At a room temperature, how does it exist? It's a
लिक्विड
oh, liquid. Well said, liquid. So there we go. We've used our powers of observation to think about water. We've used our powers of observation to think about water, but we better have a think about what it's made of.
What is
Here is my model
What is water made of?
the tiniest bit of water that we can still call water. What's its name? H2O. Hydrogen and oxygen. Well shouted there, sir. Hydrogen and oxygen. So 2 atoms of oxygen, 1 atom of hydrogen, and you get H2O. Now, if you try and chop water up any smaller, if you try and chop this shape up any smaller, you just end up with hydrogen and oxygen. A water molecule is the smallest bit of water that can exist. And the things that hold this together, like hydrogen bonding, make a water molecule incredible. And all the other things we're going to think about with water really depend on that chemistry and that physics that hold water together. Now, when I was your age, when I was really young, I could never remember H2O. I kept getting it wrong. So my science teacher drew a picture on the back of her model, and she said, David, if you're struggling to remember H2O, remember, it looks just a little bit like Mickey Mouse.
Yeah.
Oh yeah. Oh yeah. Helps me to this day to remember H2O. It's true. It's true. It's Miss Charlton, fantastic science teacher, inspired me, really did. Okay. So we know what water's made of. How can water exist? We best have a think about that. And to do that, now this time I'm going to do this without the microphone, so bear with me, people. We're going to use my water molecules. These are water molecules. These are styrofoam balls that I've drawn H2O on. So in your imaginations, these are water molecules. And you can do this with me, you can act this out with me. So at room temperature we have liquid water, and the molecules are connected, but they're connected very loosely. So get your arms above your heads, people. So they can sway, rock,
Girls like this.
swish, sway, drip, and dribble, and gush, gurgle, and we have liquid water. But then, what about if we started adding energy to these molecules? And you'll know yourself that if you get up in the morning and you've got lots of energy, you can move around faster. So the water molecules start moving faster and faster. And faster and faster and faster and faster and faster.
अरे बा
Until the molecules are moving so fast, they nearly completely break away from each other. And we haven't got a liquid, we've got a... What's the name of that gas? What's the name of that gas, people?
Water vapor. Water vapor. Water vapor. Steam.
Here we should see some steam.
अरे बा स्टीम है पत्ते
The molecules completely break away from each other and fill any space that you put them in, really. Now, the white stuff you see coming out of the kettle, that isn't steam. The white stuff you see coming out of a kettle, that isn't steam. It's too cold to be steam. What temperature do we get the formation of steam, that gas?
100.
100 degrees C, 100 degrees C. And the trouble is, all the white stuff you see, it's not hot enough, it's below 100 degrees C. It's water vapour, tiny droplets of water. Be careful about this. If you want to see proper steam, well, you can't see, it's invisible. If you want to look where it is, look about a centimetre over the top of the kettle spout. Very careful, it's hot stuff. And you'll see a clear space, because there the water is still hot enough to be a true gas. You can't see it. Steam, well done. Steam's such a powerful thing. We might just come back to that a little bit later in the show. Well done. Now then. Then we added energy to our water molecules. This time we're going to subtract energy. And you know yourselves that if you wake up in the morning and you don't have much energy, and you say, oh, I've got to go to bed. Oh, I've got to brush my teeth. Oh, what am I going to have for breakfast? You're moving slowly. So the water molecules start moving slower and slower and until the water molecules are hardly moving at all. And we haven't got a liquid, and we haven't got a gas, we've got a solid cold ice. What's that wonderful temperature at which we get the formation of water ice? Now interestingly, even at 0 degrees, the molecules don't completely stop. They're still moving a little bit, but they're so slow, you can think of them as a solid. We can think of them and they act like a solid. Great. So depending on what we do with it, let's have a look. In fact, let's have a look at some ice. I've got some ice behind here. Here's a bit of ice, people. And it's sort of colourless. And it's sort of odourless. And it just tastes cold, and we got a solid. But what's it doing in my hand? It's doing something in my hand. This thing's melting. So I wonder if we gave some energy to some more ice, could we get it to turn back into water, do you think? Yeah. Could we get it to turn back into steam? Yes. Hands up if you think yes. Okay, hands down. Hands up if you think no. Okay, hands up if you don't care. Of course you care, of course you care. Okay, let's give it a go.
नहीं चाहिए तो मुझे दे तो सगळे ने फेकत ना आइस बॉक्स है आइस तो रॉयल सोसाइटी से लंदन है they could have made a better arrangement from this place. Actually, season. Collar mics नहीं होंगे ऐसी कोई प्रॉब्लम है
The way we're going to give it some energy is by me jumping up and down.
उड़ा मारा क्या कौन बात है
So, Mr. Ice, you think you're so cool and so calm and collected. Take some of this. Oh, not so full of yourself now, eh, mate? Right. What's that, Mr. Ice? You want some more?
कैसा हुआ
Have we done it? Have we given it enough energy to turn it from a liquid or a solid into a gas? Let's have a sip. I'm not sure. What do you think?
सगळं फेक वाटतं आपल्याकडे आलं
कैमरा है ना
Bye.